completing the square. The product of a binomial square is a perfect square trinomial. And so if we look at binomial squares here, like x minus 7 squared, we know that when we FOIL that, it's x minus 7 times x minus 7. And so to get that last term, we take the last terms here and square them. So that's how we got this 49. And we know that we have double the second term because we have a negative 7x and a negative 7x. And so this one would have been times by 2 to get the 14. So basically what we want to do is undo these today to complete the square. So, and completing the square is important because sometimes what we're given to factor doesn't factor quite right, or isn't factorable using a method we've already learned. So this is another method to use to factor trinomials. And so what we need here is to figure out, if we're given this part, we need to be able to figure out the 7 from the square part of this. And so how do we do that? Well, if we have the last term, we just take the square root of it, and that's the 7. But if we have the middle term, then we have to divide it by 2 because we times it by 2 to get that. And so we're going to divide that by 2, so 14 divided by 2. And if we want to get the last term from the middle term, if the last term is missing, so say we had x squared minus 14x, and plus we didn't know what this was, so we need to find it. So we'd have to take 14 divided by 2, and then we would have to square that, because to get from 49 back to 7 we took the square root. And so if we want to go the opposite direction, we have to square it. So 14 divided by 2 is 7, and 7 squared is 49. So that's how we get this 49 here. And you can see from this one as well, if we have the 6x here, if you take 6 and divide it by 2, that's 3, and you square it, you get the 9 there. So here's another example, and really the formula for this. So whatever the middle term is, you take it and you divide it by 2, and you square it. And so whatever that middle term is then, it's really b over 2, and then it's going to be squared. So take a look at this example. If you have x squared plus 6x plus 3 squared, because if you take 6 and divide it by 2, you get 3, and 3 squared is 9. And so that's really x plus 3 squared. And so really what we're getting is that 3 right here is the 3 that ends up in your square. So here, if we want to do this, we want to find what term is added on here. Then we need to take 8 divided by 2 and square it. So 8 divided by 2 is 4, and 4 squared is 16. And so this would be x plus 4, and then that squared. So x plus 4, that quantity squared. Now, again, why are we doing this? We're doing this so we can solve equations. And so here's some equations that we want to solve, but we can't solve them the way we normally solve equations. So we're going to try this completing the square with them. So what we're doing here is we're missing this term that should go right here. And so I'm going to rewrite this as x squared plus 10x, and then plus something I'm going to put in equals 11. And be careful, because what happens if you add something to one side of an equation and you don't add it to the other? Then those equations are no longer equal. So what we have to do is we have to add it actually to both sides of the equation, whatever that number is. And that number is 10 divided by 2 and then squared. So 10 divided by 2 is 5, and 5 squared is 25. So we have to add 25 to both sides of this equation to keep it equal. And then let's do some simplifying here. We know that x squared plus 10x plus 25 is really x plus 5, and that quantity squared. And on the other side, we have 11 plus 25, which is 36. Now, how do we solve this? Well, this you should recognize from the last lesson we did as a squared problem. So what happens if we take the square root of x plus 5 squared? Well, that gives us x plus 5. And x plus 5 equals 36, the square root of 36. And be sure again that you put the plus and minus of that square root of 36. So it's going to be positive or negative 6. And so really what happens here is we're going to end up with two answers because x plus 5 equals 6 or x plus 5 equals negative 6. So we minus 5 from both of these equations. And so on the top one, x equals 1. When we minus 5 on the bottom one, x equals negative 11. And again, the reason for that is because we have this plus and minus that happens to the square root of 36 whenever it's not, when the x squared isn't equal to 0. So let's try the next equation. Again, it's x squared minus 8x plus something equals 9 plus something. That's something we have to add on to both sides of the equal sign. And that something is take that middle term and divide it by 2. So divided by 2 and then square it. So 8 divided by 2 is 4 and 4 squared is 16. So we're going to add 16 to both sides of this equation. And so we know then on this side we have x, and be careful because this is a minus 4 squared. And on the other side we have 25. And notice both are perfect squares, so we're going to take the square root. And so x minus 4 should equal positive or negative 5. And again, we have two equations we're going to write. And so x minus 4 equals 5, and x minus 4 equals negative 5. So add 4 to both sides. And so x equals 9. Or add 4 to both sides, and x equals negative 1. So two possibilities here. So solve these by completing the square. So first thing we're going to do is divide all of these by 4 since they do have a common factor. That will make the problem easier. So I'm going to divide everything here by 4 so we have a simpler problem. So if you recognize that they all have a common factor, then you can divide that common factor off. So x squared plus 8x, and then I'm going to leave my plus my space here, equals, how about 2 plus something else. And so what number goes in there? Well, I'm going to take 8 divided by 2, and I'm going to square it. So 4 squared is 16. So 16 on both sides here. And then I have x plus 4 squared equals 2 plus 16 is 18. And then I'm going to take the square root of both sides. And notice this, is square root of 18 a perfect square? It is not. So I have x plus 4 equals positive and negative square root of 18. And so I'm going to leave it like that, and I'm going to simplify this equation. And so I'm going to minus 4 from both sides. So really x is equal to negative 4 plus or minus the square root of 18. And I want to leave it that way because I can only approximate the square root of 18. And so my answer is negative 4 plus or minus the square root of 18. If I wanted to actually solve this, I would have to take the square root of 18, which is 4.243. And so I would do 4 plus 4.243 and 4 minus 4.243. And again, that's an approximation. So the top one is approximately going to be 8.243. And the bottom one is going to be negative 0.243. So those are approximations because the square root of 18 does not have a rational answer to it. finding the dimensions of a rectangle. So the length of a rectangle is 12 feet more than its width. First thing I'm going to do, draw a picture. And so width, we don't know. Length we know is the width plus 12. And so it says the total area of the rectangle is 64 square feet. So for the total area, we need to find the area of this thing. And so how do you find the area of any rectangle? Multiply its length times its width. And that equals the area that they gave us of 64 square feet. And so I'm going to do some distributive property here. W squared plus 12W. And then I'm going to leave my space, and that equals 64 plus something. So I'm going to complete the squares here. And so if I'm completing the square, then I have to take 12, divide it by 2, and then square it. So that's 6, and 6 squared is 36. So I'm going to add 36 to both of these. And so W squared plus 12W plus 36 is W plus 6 squared. And that equals 64 plus 36, which is 100. And now I can take the square root of both sides. And once I've taken the square root of both sides, I get W plus 6 equals positive or negative. Remember, you have to do positive or negative here. Positive or negative, square root of 100, which is 10. So I'm going to minus 6 from both sides. And so W equals 6 plus 10. And W equals 6 minus 10. Oh, negative 6 plus 10, and negative 6 minus 10. There's that negative right there. So negative 6 plus 10 is 4. And negative 6 and negative 10 is negative 16. And so if we go back up to this problem here, we're talking about widths. And we can either have an answer of 4 or negative 16. And one of those doesn't make any sense because you can't have a negative distance. So negative 16 is an extraneous solution. And so if it's an extraneous solution, it won't work for this. And so W has to equal 4. And W plus 12, which is the length, has to equal 16. So the width is 4 and the length is 16. And so we only have one of those answers that actually worked for this problem. I just realized I forgot to do one more problem, so I'm going to do that right now. If we have 3x squared minus 12x equals negative 54, those all have a 3 in common. So I'm going to divide everything by 3. And so I get x squared minus 4x. And plus, I'm going to do the completing the square here equals, let's see, negative 54 divided by 3 is 18, negative 18. So negative 18 plus something. And so we're going to take our 4 and divide it by 2 and square it. 4 divided by 2 is 2, and 2 squared is 4. So there's the 4 I'm going to add on to both sides. And so here I get x minus 2 squared equals negative 16, or negative 14. And then I'm going to look at taking the square root of both sides. And as soon as I do that, I say this one has no solution. And it has no solution because I know I cannot take the square root of negative 14. So this is an empty set or no solution. And I can stop right here because no matter what I do, I can't take the square root of negative 14. And so sometimes when you have completing the square, you can get a no solution or no answers. Or you can get 2 answers. Or you can get 2 answers and one of them is extraneous if we're talking about length, width, perimeter, any of those things.